Today we're talking about a true unsung hero of the energy industry, one that's working hard but completely out of sight. We're going to find out what's really going on inside these things.
You've probably seen these things, right? Maybe on a road trip through the countryside or in pictures of oil fields. They just kind of sit there, these silent, cylindrical workers, almost blending into the landscape.
But here's the thing. They're not just holding tanks. No. Inside these incredibly simple-looking vessels, something really crucial and actually pretty elegant is happening. So what are they doing?
Okay, so to get to the bottom of that, we have to talk about what a separator actually is. Really, it's all about bringing a little bit of order to a whole lot of chaos, solving a seriously messy problem that comes bubbling right out of the ground.
All right, let's just get the textbook definition out of the way. A separator is basically a big, pressurized tank that's designed to, well, separate fluids that don't like to mix. Think about your salad dressing, how the oil and vinegar always split up. It's exactly like that, just on a massive industrial scale. And you really can't overstate how common these things are. I mean, they are everywhere. From the moment the stuff comes out of the ground to the processing plant, you'll find them. Sometimes they get called different names, scrubbers or flash tanks, but at the end of the day, their job is always the same, to separate things.
Now, they mostly come in two main shapes, two flavors, if you will. You've got your vertical separators, the tall ones. Those are your go-to when what's coming in is mostly liquid. And then you have the horizontal ones, the long ones. You use those when the mix is mostly gas. So yeah, form really does follow function here.
What's really interesting, though, is how they're classified. It's not based on what goes in, but what comes out. So a two-phase separator gives you two things, gas and one stream of combined liquid. But a three-phase separator, well, that's a bit more advanced. It splits everything into three pure streams, gas, oil, and water.
So how in the world do they actually do this? It sounds pretty complicated, right? But the secret sauce, the main principle at work here, it's something you already know, something you experience every single day.
And this quote really nails it. There's no magic here, it's just plain old physics. The whole thing works because of one simple, fundamental force. Gravity. That's it. As long as the fluids have different densities, gravity will start doing its job. Okay, so check out this diagram. The messy mixture comes in from the side, and right away, instantly, the heavier stuff, the oil and water, it just starts to fall to the bottom. At the same time, the gas, which is way lighter, rises to the top. Boom. That's the first big separation, and it's all just because of density.
But it's not quite that simple. Just because the liquid falls doesn't mean the job is done. See, it's still got all these tiny gas bubbles trapped inside it, kind of like the fizz in a can of soda. So the liquid has to hang out in the tank for a while to give those bubbles time to escape to the surface. And that crucial waiting period has a name, residence time.
And how long it has to wait? Well, that totally depends on the mixture. If you've got a really light liquid, maybe it only needs a minute. But for something thick and heavy like crude oil, you're looking at more like 3 to 5 minutes. It makes sense, right? The thicker and gooier the liquid, the longer it takes for those bubbles to fight their way out.
So gravity does the initial, heavy lifting. But to get things really pure, engineers have stuffed these tanks with some seriously clever gadgets. These are the secret weapons that make the whole process work so well.
Yep. Inside, you've got this whole toolkit of components. Things like deflector plates, mist pads, vortex breakers. Each one has a very specific job to do. Let's take a closer look at a couple of my favorites.
All right, so this thing, it might look like a giant Brillo pad, right? But it's actually a super important piece of tech called a mist pad. Its entire purpose is to catch the tiny, tiny little droplets of liquid that are still floating around in the gas before it can escape. And the way it works is pretty cool. The best analogy is your car's windshield when you're driving through fog. You have all these tiny little water droplets floating around, right? They hit the glass and start to stick together. They coalesce and form bigger drops that are heavy enough to actually drip down. The mist pad does exactly that, but for the gas inside the separator.
And here's another one, simple but brilliant. This is a vortex breaker. You know when you pull the plug in a bathtub and the water forms that little whirlpool as it goes down the drain? Well, the exact same thing can happen at the liquid outlet of the separator, and that whirlpool can suck gas down with it, which you don't want. This little metal cross stops that vortex from ever forming. So simple, but so important.
Okay, so we've seen what they are and how they work on the inside. But let's zoom out. Why does any of this matter? Why is this one step so completely and utterly critical?
Well, let's think about it this way. What would happen if we just didn't use them? What if we took that messy gunk straight from the well and just pumped it right into our pipelines? The results would be, well, pretty bad. And they'd happen fast.
For starters, your gas pipelines would just clog up with liquid. The flow would grind to a halt. On top of that, your products would be totally impure, which makes them way less valuable and a nightmare to refine. And finally, you're left with this big problem of oily water, which you can't just dump somewhere. It's a real environmental hazard.
So when you think about it, the separator is kind of like a gatekeeper. It's the absolutely essential first step that makes the entire rest of the process work. Without it, none of those huge, complicated processing plants could do their jobs. They need those clean, separated streams to function.
And that's the real story of these quiet, unassuming tanks. They're making sure the fuels we get are pure, which is obviously important. They're keeping our pipelines and equipment safe, and they're protecting the environment by pulling out that contaminated water so it can be treated properly.
It's just such a great example of brilliant, simple engineering. Taking a basic force like gravity and turning it into a piece of technology that our whole energy system depends on. Kind of makes you wonder, doesn't it? What other hidden machinery is out there, quietly, making your world run?